The traffic pattern is a rectangular pattern, normally flown to the left around the airfield, and it's normally flown at 1,000 feet above ground level. It consists of 5 legs. The leg that you fly at the runway heading shortly after takeoff is known as the upwind leg or departure leg. Then following a 90-degree turn, you find yourself on the crosswind leg. Another turn to fly parallel with the runway or the downwind leg. Then base and then onto final for landing. Maintaining good control of your aircraft is key to a great pattern, maintaining the correct altitudes and the correct airspeeds. It's a great way of keeping proficient on your aircraft, so this video is going to show you how to fly a perfect traffic pattern in a Cessna 172 and how the use of virtual reality can really help you do this. Okay, starting the video off by just showing you that we don't have a load of assistance options turned on. We're flying this on the modern flight model with all of the assistance switched off. This is as realistic and as difficult as you can make it. We're using the Thrustmaster TPR rudder pedals, the Bravo throttle quadrant, and Alpha yoke from Honeycomb Aeronautical. So the first thing that we want to do is set our heading bug to the runway heading. That's going to make it easier for us to work out the correct headings for us to turn into on the various legs of our traffic pattern, and we're also going to set our altimeter so that it's recording the airfield elevation as 0, helping us maintain 1,000 feet above ground level. So parking brake off, smoothly applying the power until we have 2,300 RPM or higher. Using the rudder pedals to maintain the center line. Has a tendency to drift to the left, so putting in right rudder, alleviating that as the aircraft gets faster. 60 knots, rotate, gentle pullback, let the aircraft fly itself, and then you want to pitch the aircraft for 70 knots in the climb. This will give you a climb rate of approximately 500 to 800 feet per minute. We're using our yoke to correct our indicated airspeed. If we get a little bit too fast, we pull back. A little bit too slow, we let the nose pitch down. And as we approach 700 feet, we want to take out the notch of flaps that we had for takeoff. And we start a standard rate turn to the left. Now, so far, this is largely very similar to what you would experience on a flat screen monitor, but you will see as we get set up for our second turn, this is when virtual reality really starts to come into its own. We came out of that turn a little bit too late, but we're largely on the correct heading, bringing the RPM down to 2,000 and establishing level flight at 1,000 feet. Now this is where virtual reality really comes into its own. The airfield wants to be 45 degrees behind us before we start our turn. This is far easier to see in virtual reality by just turning your head. It was 45 degrees behind us, so we've started a standard rate turn to the left. This is going to take us onto our downwind leg of the traffic pattern. So reducing to 1900 RPM and then trimming for straight and level flight. The other great thing is that when you're not looking directly ahead, you still get a sense of whether the aircraft is pitching up or down, or whether it's rolling to the left or right. So despite looking in a different direction, you can continue to apply control input to correct for these. We want our indicated airspeed to be within the white arc because we're going to apply our first notch of flaps. We will do that when we are abeam with the airfield. Now that means we are lined up with the beginning of the airstrip. So just glance at the airfield, don't stare at it, otherwise you'll have a tendency to drift towards it. And again, VR makes it really easy just to turn your head and have a quick look at this. There's our first notch of flaps going in. We're abeam with the airfield. Reducing the power to 1700 RPM, starting a descent of 200 to 300 feet per minute. We will want to make our turn onto base, again when the airfield is 45 degrees behind us. So quick glances behind us to see when that is. So it's 45 degrees behind us, starting another standard rate turn to the left. You want to continue to descend at 200 to 300 feet per minute in this turn. We want to put one more notch of flaps in. We must make sure the wings are level before we do that. Remember, the aircraft is low and slow. If you put flaps in, which has a tendency to cause the aircraft to pitch up when you're banking and you have unequal lift on the wings, it's the perfect recipe for a stall and spin. Virtual reality continuing to come into its own here, allowing us to work out the right point at which to start our standard rate turn onto final. Many student pilots have a tendency to turn too soon, and it creates this kind of strange oval arc onto final. Continuing to descend at 200 to 300 feet. And when the wings are level, applying our final notch of flaps, establishing an airspeed of 60 knots indicated. So now we're looking at the PAPI. These are the 4 lights off to the left of the airfield. You want 2 white, 2 red. That indicates you're on the correct glide slope. More white over red means you're too high. More red over white means you're too low. You can remember this by red is dead, white is flight. Virtual reality really creates a sense of perspective here as you're descending that you don't get on a flat screen monitor. It really helps you understand your aircraft is relative to the airfield. As you get closer to the airfield, the PAPI become increasingly sensitive, so it's better to focus on the airstrip itself. And we want to start reducing the power, having an indicated airspeed of 55 knots as we cross the runway threshold. Bringing all the power out now. And flaring and just using, again, virtual reality to just peek up so that we can still see over the nose of the aircraft. Keep pulling back on the yoke, bleeding off that airspeed until the nose gently touches down. Then just let the aircraft roll and idle, taking the first opportunity to leave the runway onto the taxiway. slight touch of the brakes just to take some speed off, left rudder, a very gentle controlled taxi off of the runway. So, given that visual references are key to a great traffic pattern, virtual reality is great for this because it allows you to turn your head and look really easily at these visual cues. It also gives you that sense of inertia. Is the aircraft pitching or is it rolling, and allowing you to correct for this whilst you may not be looking directly in front of yourself. It also helps you train good muscle memory to help complement any real-world training that you may be doing. So there we go, guys, the perfect traffic pattern in virtual reality. As always, I hope you're very well wherever in the world you are, stay safe in the skies, and I will see you in my next one.